Welcome to qnawire.
Chapter 3, Problem 14 asks, what are degenerate orbitals? And says, according to Hunds' rule, how are these orbitals occupied? So there are two terms that we need to know here. The first one is degenerate orbitals. Degenerate orbitals are orbitals that have the same energy level. So if we think of an example to illustrate this, let's think of nitrogen. Nitrogen has an atomic number of 7. And so if we do its electron configuration, we know that we need to have in a neutral atom of nitrogen, we have 7 protons and 7 electrons. So we have 1s2, 2s2, and 2p3. I know this is correct because I have 2 electrons in the 1s, 2 in the 2s totaling 4, and 3 in the 2p giving me a total of 7 electrons. When I draw the orbital diagram, I'm drawing the orbital diagram in this case in terms of energy. This arrow represents an increase in energy. The electrons in the 1s orbital are closer to the nucleus, and the positive and the negative charges attract. And given that 1s is close to the nucleus, which is a small distance away, according to Coulomb's law, the electrons in the 1s orbital are lower in energy than the electrons, let's say, in a 2s orbital. So 1s will be the lowest. Then we'd have 2s, where the electrons are a bit further away, increasing the energy. And lastly, we have a 2p orbital. Again, given the shape of a 2p orbital, they're able to be oriented in 3 ways in space. So there are 3 different orbitals in the 2p system. All of the orbitals here in this 2p have the exact same energy, and therefore we call them degenerate. All 3 orbitals in 2p will be considered degenerate orbitals. The second thing we'd need to know to answer this question is Hunds' rule. And Hunds' rule states that the electrons in degenerate orbitals are filled in 1 orbital at a time. We're going to slide this over so you can see it. Not only are they filled in 1 orbital at a time, they're also filled in with parallel spins. So let's illustrate this using nitrogen. If we're going to fill in electrons into the orbital diagram for nitrogen, we'll start with the 1s electrons at the lowest energy level. This has 2, 1 up, 1 down, to have opposite spins according to the Pauli exclusion principle. Then we move on to 2s, the next lower energy, 1 up and 1 down. If we move on to 2p, we have to recognize that these orbitals are degenerate. Therefore, we have to fill in each orbital singly, 1 at a time, with electrons that have parallel spins. So my first electron is going to go into the first orbital, but my second electron is going to go into the second orbital. My third electron is then going to go into the third orbital. And you notice that all of these orbitals have parallel spins, being that the spins are all facing upward. If I had a 4th electron, I would be able to fill it into the first orbital. But according to Hunds' rule, I must fill in each orbital before I return and put 2 electrons in another orbital. This is an orbital diagram of nitrogen showing that degenerate orbitals have the same energy, and the electrons are put into each orbital one at a time singly with parallel spins before returning to place more electrons in the second orbital.